Hello Warriors, this is Miss Lemons, and today I'm going to be walking you through kind of some of the details of the density lab. So when you get to your station, you're going to have one of these little metal trays, and inside it you are going to find maybe one of these neon cards. You'll find also four different shaped pieces of metal. Now all of these metals are made of the same metal, okay? It is our job to determine the density of this metal, of each of these shapes, and then identify the metal, because remember, density helps us identify substances. Okay, so the first thing I want to talk about is how we're going to calculate the volume. So here we have a rectangular prism, and to calculate the volume of the rectangular prism, we're just going to be using a ruler, and of course we want to make sure that we're using the centimeter side metric system. So that's going to be length times width times height, and that's going to give us the volume of our rectangular prism. Keep in mind too that when you are measuring, you need to have an estimated digit. So here we are marked in the ones, or we are certain of the ones. We are also certain of the tenths, so we need to estimate to the hundredths. Make sure you're putting in precise data. Okay, so rectangular prism. The other two shapes that we have here, we have this plate, and then we also have a a cylinder. Now, the plate we can easily measure with a ruler the length and the width, right? But if we just did length times width, that's an area, and we need a volume in order to calculate density. So we also need to calculate or measure the height, which, if we look, that's pretty difficult to do using a ruler. And so instead, we are going to be using something called a micrometer. Now, you do need to know how to use this and how to read it, but you will not be using one during the actual lab unless you want to come up to my station and borrow it from me. I only have 2 of these though, so instead of having just 2 of these floating around, I'm actually having you guys use these values here. So this is as if I took the micrometer and measured the height of this piece of plate. So this thickness that we see here is 0.789 millimeters thick. That's the value you're going to use to help you calculate the volume of this plate. For the cylinder, we are going to use the ruler to calculate the height, and then to calculate the radius, it's a little bit, or the diameter, it's a little bit difficult. So again, I took my handy dandy micrometer, I measured it for you, and I wrote the value there. That is the value you will use to calculate the volume of the cylinder. So once we've calculated the volume of our other 2 shapes and we've taken their mass, we're going to go ahead and take the mass of our pellets. So this is an abnormally shaped solid, so this is a little wet. Oops, we don't want that. Okay, so we have these pellets, but we don't want to just take the mass of one pellet. That's really not enough, and we can't use a ruler or anything along those lines. So we want to take the mass of all of the pellets. So let's go ahead and just dump them in here. You would then set this on your scale balance and record your mass. I'm going to go ahead and do that now. You should probably just hang tight. So now that I've got my pellets massed in my data table, which I wrote over there, we can then move on to water displacement, okay? So that's going to involve our pellets, which I'm just going to set here, and then a graduated cylinder. You are going to be using a 100 milliliter plastic graduated cylinder, okay? Now, you're using plastic because we're going to be sliding metal in, and I don't want the bottom to crack. But for the purposes of this video, and so it's easier for us to see, I'm going to be using the glass graduated cylinder, okay? So you're using plastic, I'm using glass. The first step is going to be to fill this up about between 50 and 60 milliliters. It does not have to be perfect, and we just need to have enough water in here so that when we dump these in, they're totally under the water. So I'm going to go ahead and fill this up. All right, so I went ahead and I filled it up. It's between 50 and 60. I'm going to go ahead and adjust my camera so that it's easier for you to see what I'm doing next. All right, so you can see that I already recorded my mass, and I have a space for my starting volume, my final volume, and then the actual volume of all of these pellets. The first thing is I'm going to take a reading of the volume that is inside my graduated cylinder. Make sure that it's on a level surface. You're not holding it up in the air so that the angle of the water is wrong. And you want to make sure that you're viewing it at eye level, okay? So we've got it's a little bit higher than 50. This is marked in the ones, and it looks a little bit higher than 51. So I'd say 51.7 is what I have. So I'm going to go ahead and record that. Okay, so now I'm going to go ahead and continue with this water displacement. When we dump the pebbles in, we want to make sure that we're dumping in the same number of pebbles that we put on the scale balance. I used all of them. You should too. We don't want to just do one because the displacement is dependent on how dramatically the change in volume is. And if we only put one pebble in, look, it doesn't really change dramatically enough. So we're going to use all of them. So I'm going to just take my weigh boat and kind of bend it so I make a funnel. I'm going to angle my graduated cylinder pretty dramatically so that I don't splash water. We don't want to do that. We want to keep all the water in the base of the grad cylinder. So we're going to gently shake these into the grad cylinder. Oops, there we go. And now that I've done that, I can take my final volume. My final volume looks like it is 71.2. I'll go ahead and record that. So at this point, I just need to show you how to use this data to calculate the actual volume of those pellets. So to practice water displacement, we are going to take our final volume and subtract the starting volume from it to get the actual volume of the pellets that we just measured. So our final volume was 71.2. And yes, you need to make sure that you have milliliters there. Our starting volume was 51.7. And then we just subtract those two, and I ended up getting 19.5 milliliters. So this right here is the actual volume for our pebbles. Now, the last step of this is going to be to use these values to calculate the density. Remember that density is mass divided by volume. We have a volume, so we're just going to plug that in right here. And we have a mass, so we're going to plug that in right there. Divide the top and bottom, and we end up with our density. Now, earlier I did mention that we are using these values to help us calculate the volume. I failed to mention that, remember, this is being measured in millimeters, okay? And when we measure the plate with the ruler, we are using centimeters. So in order to calculate the volume of the plate or anything with the micrometer, we know that we're going to be using length times width times height. But when we multiply these values together, we want to make sure that they are all the same value. Or the same unit. So the length I got to be 7.65 centimeters, the width to be 7.65 centimeters, and the height I got from my little card here as 0.789 millimeters. This right here is a problem. So before you plug it into the volume equation, you need to make sure you convert this from millimeters to centimeters. The conversion, an example of it, has already been written in your data table. So use that as a guide to help you convert millimeters to centimeters. So the last thing that we need to do is dry off all of our solids, whether you have a bunch of pebbles or if you have an abnormally shaped solid, rectangles, whatever, we need to dry everything off. So I like to use our handy dandy weigh boat and some paper towels. Okay, and then the first thing we want to do is dump out as much of this water as possible without getting any solids down the sink. No solids down the sink. So I would just put your hand over the top and then kind of dump. So I'm going to go do that right now. Now that I've dumped out all the water, I can go ahead and dump all of these pebbles into my tray. And I do like to use the tray so I don't roll around everywhere. Make sure you get all of them out and then just dry them off so that they're nice and dry for the next students. Return them back into their container, and you are all done.